name is Samuel Emeka. In this video session, we shall discuss half-life. It is a topic that you see in physics, nuclear physics, chemistry, nuclear chemistry, and pre-calculus algebra. When we look at the applications of exponents in pre-calculus algebra, one of the applications of exponents and exponential functions is the topic of half-life. This is a concept of radioactivity. So please, before you view this video, you should have the knowledge of radioactivity. Some textbooks will still call it a radioactive emission, a radioactive decay. Before you view this video, it is important that you have that knowledge. That is a prerequisite knowledge. Half-life. What do we mean by half-life? Is it somebody that is living and you cut the life into two? Ocarando, half-life, ocarando. That is in Igbo language. In Igbo language. So when we talk of half-life, we are looking at the time it will take half the initial amount of a radioactive element to decay. What do I mean by that? Let's say you have 10 grams of a radioactive element. Now, what is the time it will take? Half of 10, okay, half of 10 is 5. So what is the time it will take 5 grams of that radioactive element to decay? That is what we call half-life. The time it will take for half the initial amount of the radioactive element to decay. That is the simple definition. Half-life, ocarando, half-life is defined as the time it takes for half of the initial amount, for half of the initial, or you can say original, the time it takes for half of the initial amount of the radioactive element, to decay. Because to decay or disintegrate. That is what we mean by half-life. So we shall go ahead and solve questions, and then we shall look at the formulas that we have. So I'm going to give you formulas. Question 1. A radioactive element has a half-life of 20 years. If there are 2,500 milligrams of the element initially, that tells you that the initial amount of the element, or the original amount of the element, is 2,500 milligrams. How much of the element A will have decayed after 40 years? B will remain after 40 years. Now, let's solve this from first principle. What do I mean? Let's solve it from the from the definition, without using a formula. Let's do that. So we have that the half-life of the element. The half-life of the element. Half-life of the element is 20 years. Original amount of the element is 2500 milligram. We have to put the unit. So what does this tell us? That after 20 years, half of this will decay. Half of 2500 will decay. So that tells you what? Half of 2500 is what? 2 into 25 is 12, 24, 100 is 50. 1250 milligram will do what? Will decay. After 20 years, 1250 milligram will have decayed. Then how many will remain? How many is going to remain? 2500 minus 1250 will remain. So 1250 milligram will decay, and how many will remain? 1250 milligram will remain. Let me call this half-life, part 1. We can still have part 2 to solve more problems on this. So after 20 years, 1250 milligram will decay, 1250 milligram will remain. Then after another 20 years, which means now, how many years now? 40 years. After another 20 years, which means 40 years. Half of this will decay. Half of 1250, 1250 milligram will decay. So half of this will give us what? 2 into 12, 6, 5, 2, 4, 10, 5. 625 milligram will decay. And how many is going to remain? How many will remain? 625 milligram will remain. Because it's, so you do 1250 minus 625 will remain. So 625 milligram will remain. Does that make sense? What is the original amount of the element? 2500. So how much will have decayed? How much will have decayed? It's going to be this guy plus this guy. So how much will have decayed? It will be 1250 plus 625. Which gives us what? 5, 7, 8. 1875 milligram will have decayed after 40 years. 1875 milligram will have decayed. And then how many will remain after 40 years? 625 milligram will remain. 1875 milligram will have decayed. Okay, now let's assume they ask you how much will decay after 8,000 years. Are you going to tell me you will come and you will be doing after 20 years, after another 20 years, 40 years, after another 20 years, 60 years, after another 20 years, 80 years? Come on now, folks. We don't need to do that. That leads us to what? Having formula. Scientists like you now developed a formula. Scientists like us. So I want you to take down these formulas. We now get to this, we say that the first formula, which I always like, I like this a lot, is that n subscript r is equal to n subscript o over 2 raised to power k. Where k is t over t half, t subscript half. Alright, let's define this. Nr, what I mean by n subscript r is the amount of radioactive element remaining after some time t, after some given time, let's say given time, after some given time, after a given time t, after a given time t. I like this formula a lot. Then NO, N subscript O, is the original amount. That's why R is remaining, O is original. Original amount of radioactive substance. You know what? Let's look at this as radioactive substance. Yeah, let's just use substance. N subscript O, original amount of radioactive substance. T is a given time. T subscript half is the half-life, or Carando, half-life. K is just a constant. Constant, just call it constant, a constant. That's it. That is the first formula which I really like to use. Now, if we were to solve this question here, using this first formula, it could only give us the amount remaining. It will only answer this. It's not going to answer this amount that have decayed. It will not answer it. It will only answer amount remaining after 40 years. If we were to use this formula, what are we going to do? What do we have? We have that N subscript O is 2500 milligram. Half-life is 20 years. T is 40 years. So if we were to do this, how do we find N subscript R? If we were to use this formula. Now, what we will have now will be, we will now have that K is equal to T over T half, which is 40 over 20, which is 2. So N subscript R will be 2500 over 2 raised to power 2. N subscript R will be 2500 over 4. N subscript R will now be 4 into 25, 6. 2400 is 25 milligram. You make sure you put the milligram. If you don't put the unit, I take away points. You must put the unit. If you just write 625, it could be 625 shoes. It could be 625 bags. It could be 625 pens. It could be $625. You've got to tell me 625. If I say, hey, please can you give me 625? I just ask you, please can you give me 625? What will you answer? You will say 625 what? You've got to put the unit always. It's very important. Milligram. Alright, now I'm going to give you another formula, the second formula, so that we can find how much will have decayed after 40 years. You can take down all these formulas I'm giving you. You can take it down. The second formula we have, you can now have that NTD is equal to, NTD will be equal to NO minus NR. NTD is what? This is the amount, total amount, right? Total amount of radioactive substance that have decayed, after a given time, T. Total amount of radioactive substance that have decayed after a given time T. So if we were to use this here, we'll have decayed after 40 years. What will it be? We now have that total amount here will be 2500 minus 625. And that will give us 10 minus 5 is 5, 9 minus 2 is 7, 10 minus 5, 5, 9 minus 2 is 7, 14 minus 6 is 8, 1875 milligrams. That gives you that. So this is what you can use to do that. But this is not the only formulas. We shall look into other ones. Formula number 3, we can also say that the amount remaining is equal to the original amount E exponential function lambda t. This is another formula that you have for half-life. If you want to do more work, we shall also use this formula, so I'll show you it works. Now, you will now ask me, Mr. C, what is lambda? We have a new term here. This is a Greek word. Lambda is the Greek alphabet. It's a Greek alphabet. Lambda. This is what we know as decay constant. Decay constant. Then you ask me now, what is decay constant? That is what you will ask me. What is decay constant? Is defined as the ratio of the rate of radioactive nuclear decay. We call it decay constant or disintegration constant. Some textbooks might have it as a radioactive constant. Disintegration constant. This is the amount of radioactive element decaying per unit time all over the amount of radioactive substance remaining. The rate of radioactive nuclear decay, which means the amount decaying per unit rate is per time, per unit time. So if I don't want to put per unit time, I just say rate. Rate of radioactive nuclear decay. So the amount of radioactive nuclei remaining in the radioactive substance. That is what we know as the disintegration constant. This is a very important concept. Now, I'm going to give you a formula for, we have a relationship between a half-life and disintegration constant. So take down the first formula. We have that lambda, disintegration constant or decay constant, is equal to the 2 over T half. And if you want to take down the fifth formula, half-life is equal to the 2 over lambda. Now, please, this is derived. These formulas were all derived. And I'm not gonna, if I start showing the proof now, you will say, what is this man doing? Don't tell us the proof. So, but this is actually derived, but we're not going to go into, we will not go into the proof. Let us just learn the application, use the formulas to do the application. Let's use this formula and solve this question 1. In fact, that means I'm going to use my calculator as usual, because we are going to have a ln. Ln is a natural logarithm. That's the ln. Please, natural or material logarithm. Please, view my videos on logarithms. Logarithms has a playlist. View the videos there. Then you will know what I mean by that, by ln. Ln of x means log to base e of x. Into x is log to base e of x. We've talked about it. Now let's use this formula and solve question 1. If we use this formula, we see that n subscript O is 2500. T is 40 years. T half is 20 years. Let's find the decay constant will be ln 2 over T half, which is ln 2 over 20. What I have now is that the amount remaining will be 2500 times e exponential function to negative ln 2. Let's go ahead and do ln 2 over 20 times 40. If we have a lambda t will be ln 2 over 20 times 40. 20 here, this is 2 ln 2. So this is a 2 ln 2. 2 ln 2. 2 times ln 2. 2 times ln 2. Alright, now what you have to do, you come here. I mean, it depends on the calculator you use. Please, I have also, I did this in the video on interest and annuities, compound interest. It is application of exponential functions too. I did how to, you can use the calculator in your computer, or you can use any calculator to do it. If we now do this, this will be, I have a 2 times ln 2. I have this, then I shift E, negative, shift answer, 0.25. This gives me 0.25. 2500 times 0.25 times 2500, and that is 625. milligram. So you can use anything. You can use any formula. That is up to you. You can use any formula. But I'm gonna, we can use both of them. It does not matter. We can use both formulas, the first one and this one. Let's solve more questions. Question 2. A 1200 kilogram of a radioactive element kept decaying for 50 years until 300 kilogram of the element remained. What is the half-life of the element? Let's use the first formula I gave you. First of all, let's find K. Let's find K. Here, you write out what you have. Our NO is what? 1200 kilogram. Our T is 58. Our NR is 300 kilogram. I am doing varieties so that you will understand it. Let's go ahead and find a K. This means that 2K times NR is NO. 2K, 2 exponent K is NO over NR. So 2 exponent K is 1200 over 300. 2 exponent K is 4. 2 exponent K is 4. That means that 2 exponent K is 2 squared. 2 squared. They have the same base, so equate their exponent. K is equal to 2. Then K is equal to T over T over half-life. We now have that 2 is equal to T over half-life. 2 times half-life is equal to T. That means that half-life is equal to T over 2. Half-life is equal to 50 over 2. So the half-life is 25. 25 what? You don't put 25. 25 what? Years. 25 years is the half-life. That's the half-life. 25 years. What if we did this with the other formula? Let's do it with the other formula. With the other formula, it will be NR equal to NO E minus lambda T. We have that E minus lambda T. Let's find the decay constant first. Let's find the decay constant. NR over NO. Please, if you want to know how I'm doing this, you have to view my video on literal equations. Literal equations. I hope you have an idea of that. I switched this, then I divided both sides by n subscript O. View my videos on literal equations. We now have that. How do we do this? Let's find the decay constant first. Because if we find the decay constant, then we can find the half-life. How do we get this? We have to introduce ln. Introduce ln to both sides. Introduce ln or log to base e to both sides. So we have that ln e negative lambda t is equal to ln n subscript r over n subscript o. I've got to use here. We now have from there that that negative lambda t, because this is the log to base e. That gives us negative lambda t equal to ln nr over no. And so what would this be? You divide both sides by negative t, lambda will now be being NR over NO all over negative T. And you can bring the negative up. It doesn't, we don't write negative in the denominator. So this is negative ln NR over NO over T. Alright, so this will be what now? What will it be? Negative ln, what was our NR? That was a 1200, right? 1200. No, that was 300 over 1200. That was 300 over 1200. All over, what was our T? Our T was 50. Our T was 50. Okay, folks, what would this decay constant be? What would it be? Negative ln, this is 1 over 4. 1 over 4 is 0.25 over 50. So, lambda is equal to, actually, we can go ahead and get this done. Lambda is ln 2 over half-life, and that is negative ln 0.25 over 50. We can cross multiply T half-life times negative ln 0.25 is equal to 50 ln 2. So half-life is equal to 50 ln 2 over negative ln 0.25. Half-life is equal to negative 50 ln 2, negative 50 times ln 2 all over ln 0.25. Alright, we can now solve it. You can now solve it. So what we have to do is we have to find, first of all, I've got to do ln 0.25. It gives me negative 1.386294361. That's a negative. So negative in the numerator divided by this negative is positive. Now let me do 50 ln 2. You know what? I can do 50 ln 2. This me what? Divided this 34.65735903. Then divided by ln 0.25. I can do it that way. Yeah. So this gives me 25. 25 years. 25 years. That's it. Can do it. Let's look at question 3. Sodium 24 is used to locate obstructions in blood flow. It has a half-life of 15 hours. If a procedure needs 0.75 gram and is scheduled to take place in 2 days, what is the minimum amount required now? Required now. Round to the nearest 10. Let's look at it. Let's write the parameters. Half-life of sodium 24 is 15 hours. 15 hours. Let's kind of write the unit here because I see this here. Now, if a procedure needs 0.75 gram, now what is the minimum amount required now? What are they asking for, folks? They're asking for the NO. That is what they're asking for. That is what they're asking for. So this means that the procedure needs 0.75 gram. And the time is 2 days. 2 days. It is good to always write the unit. I don't think we wrote the unit in the parameters. It's good to write the unit. As you write the parameters, it's good to write the unit. Because now we have 2 days and we have 15 hours. They are not in the same unit. They should be in the same unit. So 1 day is how many hours? I don't know. Remind me, 1 day is how many hours? Don't mind me. 1 day is 24 hours. So 2 days is 48 hours. 48 hours. This is 48 hours. 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 Hour. Is it hour or hour? Hour. 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 Hours. Hours. Now, they want us to find the original amount. Let's use the first formula, the one I like. N subscript R is NO over 2K. What is our K? K is T over T half, which is 48 over 15. 48 over 15. Will it give us, that is 16 over, this is 16 over 5, which is 3, 15.10, 2, 3.2, right? 5 into 15, 3, 15, 1.10, 2, 3.2. Now, NO is what? N subscript O is NR times 2K, 2 exponent K. This is 0.75 times 2 exponent 3.2. What is this going to give us? 2 exponent 3.2. 2 exponent 3.2 is equal to this times 0.75. So this is a 6.89219,013. To the nearest tenth is 6.9. 6.9 what, folks? 6.9 gram. 6.9 gram. To the nearest tenth. What if we decide to use the other formula? Doesn't matter. N subscript R is equal to NO E minus lambda T. So NO is N subscript R over E minus lambda T. And then let's get lambda T. Lambda T is ln 2 over half-life times T, which is ln 2 over 15 times 48. And that is 48 ln 2 divided by 15. That's a lot. 2.218070978. 2.2. Please, let me give you an advice. Don't round. Do not round until the final answer. 2.218070978. Do not round until the final answer, because if you round in between, then you might not get the answer right. Now this will give us NR is 0.75 over E 2.2 negative 2.218070,978. So let's do E of the shift, E negative of the answer. That gives me 0.1088188,204. And then I now do 0.75 divided by the answer. And that gives me 6.9 gram. Yeah, the same thing. Question 4. Please pause the video. As usual, before I solve a question, you pause the video and try to solve it on your own first. Then before you play and see whether we got the same thing. 4. 175 gram of a 200 gram radioactive element decayed in 87 hours. What is the half-life of the element? Now we have a 175 decayed. This is a little bit tricky. This is a little bit tricky. It says 175 gram of a 200 gram. That means that N subscript O is 200 gram. 175 gram of the radioactive element decayed in 87 hours. T is 87 hours. Now, the amount decayed, ND, N subscript D, amount decayed. Remember, the N subscript TD, I put it as total amount decayed. This is amount decayed, is 175. So, but that is not what we want. Now, what is the amount remaining? You have to be careful about these questions. You have to be careful about these questions. Is the original amount minus the amount decayed, which is 200 minus 175, which is 25 gram. 25 gram. So this is what we are going to use here, folks. This is what we'll use to solve the question. Now, this will now be what? What is it going to be? They're asking us for the what? Half-life. I will just use the first formula to do this. N subscript R is NO over 2 exponent K. 2 exponent K is N subscript O over N subscript R. 2 exponent K is 200 over 25. 2 exponent K is 8. 2 exponent K is 2 exponent 3. So K is 3. K is 3. But we've not finished. Okay? K is equal to what? T over T half. T half is equal to T over K. T half is equal to, the time is what? 87 hours. 87 over 3. So T half will be 3 into 8 is 2, 6, 27, 9. 29 what? 29 hours. Hours. 29 hours. You see, we are doing varieties. Question 5. Americium 24. Americium 241. Americium 241 is a vital component of household smoke detectors. It has a half-life of 432 years. 432 years. How many years will it take a 10 gram mass? 10 gram mass. How many years will it take a 10 gram mass of americium 241 to decay to 2.7 gram? It will have to decay to 2.7 grams. So the amount remaining will be 2.7 grams. And they're asking for the what? For the time. T is what they're asking here. In this question, they're asking for the time. If I use the formula I like best, if I use it first, NR is NO over 2K. 2K is NO over NR. 2K is 10 over divided by 2.7. 10 divided by 2.7. This is gonna give me. This will not give me. In this case, In this case, you see that it's not gonna give, because this is 100 over 27, and that is not a multiple of 2. So that means what? How do I find K? How do I find K this time? I have to introduce log. I just got to introduce log. Introducing log, this wasn't like the previous question. Introduce log to both sides. To both sides. Now I have that log 2 exponent k is equal to log 10 over 2.7. Because 100 over 27, 10 over 2.7 is the same thing. Equivalent fraction is 100 over 27. It won't give me a multiple of 2. It will not. So that means I'll have to introduce log. Now this is k log 2 will be log 10 over 2.7. That means that k will be log 10 over 2.7 all over log 2. But my k is what? But my k is t over t half equal to log 10 over 2.7 over log 2. That means that my t half will be, now, that means that my t half will be t log 2 over log 10 over 2.7. So my t subscript half will be, my half-life will be, my t is what? Oh, we are looking for t, not the half-life. We are looking for t, not the half-life. So this will be t log 2 is t half-life times log 10 over 2.7. So my t will be half-life times log 10 over 2.7 all over log 2. So my t will be, the half-life is what? 432. 432 times log 10 over 2.7 all over log 2. Now, let's find what our t will be. I will first of all do what? I'll do 10 divided by 2.7. Then I do the log of the answer. Log of the answer. Then I do times 432. So I keep that. It gives me a log of the answer gives me 0.5686362358. And then when I multiply by 432, I have 245.6508539. And I got to divide this by log 2, divided by log 2. So I have a 816.0. What I have here is 816.034473. If you have a time, you round it up to the nearest integer. So this is 816 years. Yes, yeah, approximately 816 years. Now, you know how I put approximately like this? This is approximately like this, approximately 816 years. What if we use the other method to do this? If I use the other formula, I have that NR is NOE negative lambda t. Let's find our t. E negative lambda t is NR over NO. Introduce lean to both sides. I have that lean E negative lambda t is equal to lean NR over NO. So negative lambda t is lean NR over NO. T will now be what? What is T? T will now be lean NR over NO all over negative lambda. And what will it be? T will be negative ln NR over NO all over lambda. T will be negative ln NR over NO all over. Lambda is what? Ln 2 over half-life. Ln 2 over half-life. See that? I'm trying to simplify everything so that I'll just have to substitute in the formula. That is what I'm trying to do. But you must not do it my way, okay? You mustn't do it my way. This means negative ln NR over NO. I know some of you will say, this guy is just wasting time in this video. Divided by ln 2 over half-life. I know what I'm doing. I'm just breaking it down. I should have just put it, but some of you might ask me, what did you do? Negative ln NR over NO times half-life over ln 2. So we have that T is negative half-life ln NR over NO all over ln 2. So T will be negative, half-life is what, 432 times ln NR is what, 2.7 over NO is what, 10 all over ln 2, all over ln 2. So we come over here, I'm going to do 2.7 over 10 is 0.27. Ln 0.27 is going to give us a negative. That gives us a negative, and negative times negative is positive. So negative 1.309333332 times this negative 432. That goes. And then times 432. Negative times negative is positive. Times 432, that gives us now 565.63199942 divided by ln 2, and that is 816, approximately 816 years. Approximately 816 years. That's the same answer. Okay? Question 6. Carbon 14 is a natural radioactive carbon isotope in living organisms. It is constantly renewed as the organism lives and begins to decay when the organism dies. If the half-life of carbon 14 is 5,730 years, how old is a mummy having only 70% of the normal amount of carbon 14? Now, let's write the parameters. We have that half-life, right? Half-life of carbon 14. Half-life is 5730 years. Yes, that's a lot. How old is a mummy having only 70% of the normal amount? So they're asking us for the T. That is what they're asking us for. They're asking us for the T. Then, in this case, 70% of the normal amount, that's the amount remaining. The amount remaining is what? 70%. What is the original amount? What is the total percent? It's 100%. That is what it means. So, in this case, they did not give mass in gram or milligram or kilogram, as the case may be. They gave 70%. That means the total is 100%. So if it was 70 gram, the total would be 100 gram. If it was 70 milligram, the total will be 100 milligram. That is the way we do it. If it was 70 kilogram, the total is 100 kilogram. So that is what they mean. They get 70%, that means the original amount is 100%. Now, some folks will use 0.7 here. And that is good if you want to use 0.7. 70% is 0.7. But if you're going to use 0.7 here, you use 1 here. If you're going to use 7 here, you use 10 here. If you're going to use 70 here, you use 100. What would Mr. C like to use? 70 and 100. That is what I would like to use. But you can use any one. You can use 0.7, you use 1. You can use 7, you use 10. You can use 70, you use 100. If I do it the first, my way that I like, this is 2 exponent k will be NO over NR. That means that 2 exponent k will be NO in this case is 100 over NR 70. I have to introduce a log. So log 2 exponent k is log 100 over 70. K log 2 will be log 100 over 70. K will be log 100 over 70 over log 2. And my K is what? T over T half. T over T half. T over T half is log 100 over 70 over log 2. So that means that my T is equal to T half times log 100 over 70 is what? 0, because, well, let me use 100 over 70. 100 over 70. Right? Let me make sure I'm doing this well. All over log 2, and my T will be 5730 times log 100 over 70 over log 2. So let's find the time. Yes. I'll do 100 divided by 70 first, which is 10 divided by 7. 1.428571429. I get the log of it. Log of the answer. Log answer. That gives me 0.1549096. Then times 5730. It gives me 887.5882307 divided by log 2. And that gives me 2948.50428. So how old? If you're asking, if somebody is this, how many years old? Because if you're 29 years and some months, but it has not reached your next birthday, you are still 29 years, right? So this is how old? This is 2948 years. You don't come and start running up to 2949 years, no, because you have not reached your next birthday. So 2948 years. You really thank God.